Hello, welcome to topic 5 in Algebra Bootcamp, domain and range. So this is a topic that can be covered in a multitude of ways. Today we're going to cover it both graphically, so in a visual way, and also algebraically. But you can always graph something on your calculator to make it visual. So as we know, or should, domain is what our x values can be, range is what our y values can be. Domain is usually asked about more because it's easier to look at a function, that's defined by x and see what x can and cannot be. Whereas range is easier to do visually, so that's what I would ask you to do. To find range, it would just be a visual way. Domain can be asked both graphically, like in a visual way, and algebraically. All right, let's take a look at this first example. This is a parabola, and it's opening up. And so let's first take a look at the domain, the x values. So visually, if something's graphed, we want to look at it from left to right. Now, it doesn't look like it's taking on all these values, but it actually is. This is forever going to the left slightly. And so it's going to take on every single x value all the way to negative infinity, and then therefore also to positive infinity, because it's also going to the right and up infinitely. So our domain is everything. So the way that we write that is our domain is all real numbers, which we can write from negative infinity to positive infinity. Then our range, our y values, are what's restricted. Range, we look down to up. So our range, the lowest value, y value that this graph takes on is actually down here at -4. It takes on that value because we clearly have the coordinate point 1, -4. So the lowest y value that we take on is -4, and since we take it on, we put it in brackets. Then we're not restricted going up as we're going infinitely up towards positive infinity in the y direction. So we say our range is from -4 to infinity. Anytime you have negative or positive infinity, you have open parentheses. Just because we can't really capture infinity, it's a concept, not a number. But in this case, since we reach -4 here in the y direction, we hit -4 as a value, so we capture it with a bracket. All right, here we have a parabola also, but this one's not a function. You see it doesn't pass the vertical line test. Either way, it's just a sideways opening parabola, so this would be a y-squared parabola. So our domain here is restricted. If we look left to right, we see that we don't go infinitely to the left here. And actually the smallest x value that we hit, the most to the left point, is right here. That x value is -3. So our smallest x value is -3, which we can hit. And then we extend infinitely to the right, as shown by the arrows, so our domain is -3 closed to infinity. Our range in this case is everything. Range, again, we look down to up, and so this goes forever downwards, this goes forever up, and so our range is not restricted at all. Our range is all real numbers. All right, our last one is a line. It's a linear function. Anytime we have a line, unless it's horizontal or vertical, so if we have any sort of oblique line, like this.
Playing from Ian's iPhone.
Okay, don't know why my Alexa just went off there, but all right. So we have a line here, and it's going forever down and to the left, forever up and to the right. Neither our domain nor our range are restricted at all, so both of them go from -infinity to infinity. And again, that's for any linear function, right, except if it's horizontal or a vertical line. That would be the only time when we have lines that have restricted domains or ranges. All right, on the next slide, we're going to take a look at some algebraically based problems to find the domain. And if you'd like, you can grab your calculator and graph them to follow along. All right, so let's take a look at some functions represented algebraically rather than graphically. We want to find the domain of each function. Again, you could totally graph these in your calculator. You have that resource to use. However, if you just think about these two times when there are issues, Basically, if you have x in a denominator or if you have a square root. Or, any root that's an even index, 4th root, 6th root, but mainly a square root is what we'll see. If you don't have either of those things, like x in a denominator or x under a square root, then you're most likely not going to have an issue with your domain, and it's just going to be all real numbers. But we can see with A, B, and C, we have those issues, and so we potentially are going to have a restricted domain. So if you just look at A, right, we don't care about the numerator. The numerator can equal whatever, doesn't matter. It can equal 0, that's fine. But the denominator can't, right? We can't divide by 0. So if you just look at this denominator, you can clearly see the value of x that makes it 0 is 2. So we can include everything but 2. Now, what is that? How do we write that? Well, the way that we write that is we want to go all the way from negative infinity to infinity, but we can't include 2. So we go to 2. We cannot equal 2, so we have open parentheses, union. We want to jump over 2, so we're not including it, and then we can go all the way to infinity. So this is including every single number from negative infinity to infinity except 2, because 2 is our issue. It makes the denominator 0. Therefore, our domain is every single real number except 2. All right, let's look at part B. So part B has a radical. And if we take a look at B and just do some work down here, we can see that what's under the square root needs to be positive or 0, because again, we can't take the square root of anything that's negative. So in order to force what's under the radical to be positive or 0, we literally will write it like that. So we'll say, hey, 2x minus 1, it needs to be greater than or equal to 0. This is forcing what's under the square root to be a positive or 0. We can take the square root of 0, that's okay. All right, solving this, we'll add 1 to both sides, and then we'll divide by 2. Remember, solving an inequality is just like solving an equation, except if you divide or multiply both sides by a negative, you have to flip the sign. We did not have to do that in this case. So we need to force x to be greater than or equal to 1/2. So to write that, to force x to be greater than or equal to 1/2, that means 1/2 is the smallest value we can be, and we can equal it, that's okay, because it's or equal to. So our domain goes from 1/2 and everything greater than it. This is writing this right here in interval notation. Okay, for part C, this one might not be as simple to just look at and see like part A was. So if you can see what x would be to make this 0, if you could see that it's 4, right? 2 times 4 would be 8, minus 8 is 0. That's fine. You can just exclude 8, just like we did excluding 2 up here. But if you don't see that, what you can do is take that denominator and say, hey, this cannot be 0. And then we'll just solve. So we'll add 8 to both sides, and then we'll divide both sides by 2. So we clearly see that x cannot be 4. That means we need to exclude 4 from our domain, so we can be every single number except for 4. So this is really going to look just like the answer in part A, except we're excluding 4 this time. So we can go from negative infinity to 4, but not include it, union 4, not including it, to infinity. For part D, if you were to graph this, it's just a line, right? It's y equals mx plus b. And so this is just a line in slope-intercept form, and a line has no restrictions on the domain because it's an oblique line. It's not horizontal or vertical. Well, it's not vertical. And so we don't have a denominator, we don't have a square root. So our domain is not restricted at all. Our domain here is going to be all real numbers. And there's no work involved for that one. All right, I selected 5 problems for you to try on your own. This will help you out to get some extra practice problems. So go ahead and write these down. I'm going to pause, write the solutions. I suggest you do the same. Then you can play the video and check your work. Okay, here are the solutions. I did include work for, well, 4 of them that needed work. So again, these are ones A and B had x in the denominator, so we could not let the denominator equal 0. This one barely required any work. We excluded 0 from the domain. Similarly, we had to exclude -6 from the domain in part B. Part C was a polynomial function. It's a parabola. The range would end up being restricted, but the domain wouldn't be. X is not in a square root or in a denominator. Part D, just because it's negative out front doesn't mean we deal with it any differently. We still make sure that the radicand, what's under the square root, is positive or 0. And then we solve from there. So we have x has to be greater than or equal to -1/4. So the smallest value we could be is -1/4. We can be that because it's or equal to. Then part E, we had a little bit of algebra here. We'll zoom in on that. We had to let the radicand again be greater than or equal to 0, so I subtracted 2. Then we had to divide by a -1 here to get x. So when we divide by a negative, we have to flip the inequality. So x actually has to be less than or equal to 2. So the biggest value that we can be is 2, and we have to be less than it. So -infinity all the way up to 2, including 2. All right, take a look at these. If there were any you didn't understand, make sure you work through them, take a look at the work, and then next will be your daily assignment. Here is your assignment for today. Please note that in number 7, this 1 plus does not affect anything whatsoever. We still deal with just the square root. Go ahead and pause, write these down, and then upload to Blackboard. Remember, tomorrow you will have a quiz review. It will be me giving practice problems in a video. You pause your screen, work through them, and then make sure your answers are correct and make any necessary changes. I will also have your first quiz on Blackboard that you can download and then upload your solutions by Friday at noon. All right, guys, take care.